Hello everyone. In this video, we will take some examples of converting a hexadecimal number system to a decimal number system. In lecture 2 of this course, we did study how to convert a binary number system to a decimal number system. Now we will use the same law to convert the hexadecimal number system to a decimal number system. This law is used to convert from any number system to the decimal number system. Let us take an example and see how to use this law. Example: convert the hexadecimal number 5b2 to the decimal number. We take the first right digit, this 2, multiply it by the base 16 to the power of 0, plus the next left digit, this b, which is equal to 11 in decimal, multiply it by the base 16 to the power of 1, plus the last digit 5, multiply it by the base 16 to the power of 2. This equal to 2 times 1 plus 11 times 16 plus 5 times 256. Equal to 2 plus 176 plus 1280 equal to 1458. So the number 5b2 in hexadecimal is equal to 1458 in decimal. Let us take another example with a decimal point. Convert the hexadecimal number C2F.4a to the decimal number. For convenience, we will take the number as two parts, the integer part and the fractional part. Then we add the two converted parts together. First, we will convert the integer part, which is C2F. By applying the previous law, we take the first right digit, this f, which is equal to 15 in decimal, and multiply it by the base 16 to the power of 0, plus the next left digit, this 2, multiply it by the base 16 to the power of 1, plus the next left digit, this c, which is equal to 12 in decimal, multiply it by the base 16 to the power of 2, equal to 15 times 1 plus 2 times 16 plus 12 times 256, equal to 15 plus 32 plus 3072, equal to 3119. So the number C2F in hexadecimal is equal to 3119 in decimal. Now we will convert the fractional part, which is 0.4a. To convert the fractional number, we will take the first digit after the decimal point, this 4, and multiply it by the base 16 to the power of minus 1, plus the next digit, this a, which is equal to 10 in decimal, multiply it by the base 16 to the power of minus 2, equal to 4 times 1 over 16 plus 10 times 1 over 256, equal to 0.25 plus 0.0390625. This is equal to 0.2890625. So the number 0.4a in hexadecimal is equal to 0.2890625 in decimal. Now we will add the two converted parts together. The converted integer part was 3119 plus the converted fractional part, which is 0.2890625. This equal to 3119.2890625. So the number C2F.4a in hexadecimal is equal to 3119.2890625 in decimal. This course is sponsored by the Logic Kit app. With the Logic Kit app, you can learn and solve number systems and boolean algebra with step-by-step solutions. Let us use this app and convert a hexadecimal number to a decimal number, and see how this app explains the steps. In the Convert Number section of this app, we select the input base, which is 16, and the output base, which is 10, and write a hexadecimal number, for example, FB3C.5D1. As we can see, the equivalent decimal number is 64316.363.52539. Now let's see the steps. As you can see, the app first converted the integer part of the number by applying this law and doing the calculations with explained step by step that you can follow to understand the solution. Then you see the steps of how to convert the fractional part of the number. Also, the steps are explained very well. At the end, it added the two converted parts and give the final solution. This app is giving you the ability to convert from any base to any base up to base 36. Also, by this app, you can find the complements and do arithmetic between numbers in different bases. And in the boolean algebra section, you can do a lot of things like minimize the functions, solve the Karnaugh map, deal with truth table, and many other things. I will leave the link to download the Logic Kit app from the App Store in the description. Don't forget to subscribe to the channel, follow us on social media, all links are in the description.